we did have people in the past who were like, well, I want my system to be 90% accurate. And then we're like, on what? And they're like, no, 90% accurate. And it's like, well, that like, what you're doing with your system will decide about how successful your system is. And that's what you want to measure, and that's what you want to focus on. And I can see how this sometimes gets lost if you don't not thinking about it, and if all you follow is like research, which is has kind of a slightly different objective because you're comparing algorithms.
You're listening to Gradient Descent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Biewald.
Today I'm talking to Ines and Sophie. Ines is the co-founder of Explosion AI, which is a digital studio specializing in tools for AI technology. She's a core developer of Spacie, which is one of the leading open source libraries for NLP and Python, and Prodigy, which is a data annotation tool powered by active learning. Sophie is an NLP and machine learning engineer at Explosion AI, and she has more than 12 years of experience in NLP and machine learning, including in the pharmaceutical industry and the food industry. I'm super excited to talk to them today.
Hi, I'm Ines. Some of you might know me from Spacie, which is an open source library for natural language processing in Python. And our company is called Explosion, and we specialize in developer tools for AI, machine learning, NLP specifically. And so we build tons of open source tools that are quite popular, which is really cool. And we also have a commercial product, which is called Prodigy, which is an annotation tool for creating training data for machine learning models. And it's a developer tool. It's fully scriptable in Python, so you can use it to script your own custom data flows, your own custom labeling recipes, put a model in the loop. There's all kinds of cool stuff you can do with it, and that's what we do. And we're currently working on version 3 of Spacie, which we're very excited about, and which really kind of finally take Spacie to the next level, let people use all this really new, modern, cutting-edge NLP stuff. And we're also working on Prodigy Teams, which is more of a software as a service extension to Prodigy, and really lets you scale up your annotation projects and manage large annotation teams, but without compromising on the data privacy and scriptability.
Okay, so before we like jump into the details of your library, just as a fellow entrepreneur, I have to ask, like, tell me the story of how did you start this and what was it like?
Yeah, so I mean, Spacie started when my co-founder Matt left academia. So he was working on NLP. He was researching, publishing stuff, but he always tells the story as like he got to the point where he had to write grant proposals, and at the same time, which he didn't want to do, and at the same time, he was realizing that people were using his research code in like production niche environments, which was kind of ridiculous because it was still research code. So it's like, well, there's clearly something there. So he left academia and started writing Spacie as an open source library. And then shortly after that, we met here in Berlin, and we started working together. And initially, I was working on more like visualizers for the library, which are still like an important part of what people like about Spacie, but I was a bit skeptical at first. Like, my background is not NLP specifically. I've always programmed, but like, I did linguistics, but my first reaction was like, it sounds kind of boring. I'm not sure if I want to.
Really?
Yeah, so like quite literally. Yeah, so he was like, I'd love to have this syntax visualizer. And I'm like, I know totally what it is because I know like linguistics, but I was like, that sounds, I don't know if I want to do that. I'd rather work with something else. But I did, and it was good.
Yeah. And it's still very popular, right?
Yeah, I feel like people still. I think when people think about Spacie, they think about our like syntactic visualizer a lot. So
yeah,
I'm glad I did it.
That's my impression.
Yeah,
it's quite beautiful. Yeah.
So that's how it all started. And then at some point we were like, well, okay, we want to found a company around this, but we also knew we didn't want to go down this typical startup route because we saw, hey, look, there's tons of money to be made. We can just run our company. We can actually, we don't need to run at a loss. We don't need to have like, this crazy scale in the beginning. We can just build stuff and make money doing it. So that's how we set up the company. And we're fully independent, which is cool and gives us a lot of opportunities. And we're now a small team of, I think, 8 people at this point, including Sophie, who was, I think, one of our first full-time NLP people who joined the team.
Nice. And so, Sophie, how long have you been working with the team?
So I guess I started working for Spacey at the beginning of 2019, so almost 2 years now.
Wow, yeah.
I think I met Ines in a pub in Brussels
Yeah.
after
I mean,
an NLP meetup.
yeah. It's not like we met randomly.
I see.
No, exactly. So there was definitely a theme to the day, and I think I really loved their vision, not just for how to run a company, but also on how you should iterate over data and your models, and just this very pragmatic view on how to apply machine learning in an industry context, really.
Because I guess you've also seen seen this done okay, but also you've seen this done quite badly in maybe some contexts.
Exactly. So my background is I do have a PhD in bio-NLP, so on biomedical texts.
Cool.
But then I worked for Big Pharma for 3 years, so J&J, and indeed there's many examples on how to apply machine learning models and how not to apply machine learning models. And I've always been I think working in open source is just the best thing there is. So they didn't need much convincing, I think, to start working.
Well, we'll get into the technical details in a second, but I have to ask, so how do you make money? Like, how does your business operate with these open source products?
We sell a product. So we do this really crazy thing where we sell something and people give us money, and then we spend less money than we make, and then we make a profit. No, but it's like, awesome. So Prodigy, you can buy Prodigy, and we sell Prodigy for a lifetime license, so it's a one-time fee. Then a great thing about software, being in the software business, is you can sell a piece of software and then you can sell it again. So software,
but you do have an open source model, right? So what parts are open source and what parts are for sale?
So we've never really liked this idea of having this sort of freemium thing or this kind of open core, because the problem there is that it introduces a lot of questions, and it puts you as a company in a very weird position, because we want people to have a very easy time using our tools. Like, we want our docs to be great. We don't want to sell help with our own software. So if we did the consulting model where we sold stuff on top of Spacey, we'd constantly be in this position where we're like, well, if our docs are too good and our library is too good, nobody gives us money. But if it's too shit, then nobody wants our services because they're not going to use our tools. So we never wanted that. And then we also think it's kind of, there's always a difficult story around an open source library if you suddenly have these components that are free. And in general, algorithms is not really what I think is the thing that you should be selling. There's developer experience. That's something that makes companies a lot of money. That's something people will be paying money for. Just that's a big thing why people use and pay for weights and biases, for example. That's developer productivity. Same with data, anything around creating data. That's where the real customization comes in. That's the valuable stuff people are working on, and that's also where products maybe. So we have a separate product that probably you'd be interested in if you're a power user of our open source tools, but it's separate. Spacey is free, the code is open source, and we sell additional products to it.
And is the additional product Prodigy?
Yeah, that's currently the one product we have, but we also, as I mentioned earlier, we're working on Prodigy Teams, and that will have a more SaaS type of model that people will be paying for.
I see, but Prodigy is software that I could buy one time.
Yes, yeah. So you can go online right now, go into online shop, buy it, download it, pip install it, use it. Gotcha. So that's also the idea. We want to, we really want to make the path for a developer as easy as possible, and make it easy to start using our tools. And then there's a lot more, you can be doing.
And I guess the typical person that you sell to, and the person that uses Spacey, is someone working in natural language processing, trying to build models. Do I have that right?
Probably developers at all kinds of companies, from top Fortune 500 to startups to academics, researchers. Also, a lot of people are getting into NLP now who don't have the classic machine learning background, as in computer science PhD and then startup or something. It's a lot of people in digital humanities, from the medical field. There are lots of people entering the field now who want to solve problems, and that's what we also find very interesting, because they bring in the domain knowledge. They have a problem they want to solve. They know how to solve it, and then they're learning machine learning, which I would say is often a better path to success than coming from the other direction, knowing machine learning and then thinking about what problem in the world can I apply to. I think a lot of terrible products have been born out of, especially a very naive or arrogant view on approach to this sort of thing.
So Spacey, your library, let's talk about that. I mean, I want to say before we talk about kind of the new things you're doing, maybe for someone who hasn't heard about your library, looked in detail, like what are the big components and what was it designed to solve?
Well, Spacey was initially developed to really process large volumes of text at scale efficiently. So, you want to process the whole internet. Well, the internet's not going to get smaller. Computers are not going to get faster. So, you want to have very efficient software to do it. And it started out by just having, and also it was always designed to be used in production and in industry use cases, which was, especially at the time when we started, wasn't such a consideration. Most code is written for research. So Spacey really took the other approach and said, okay, look, you want to process text and do stuff with text. We're giving you one implementation, which we think is the best. We're not giving you like 50 parsers that you can all like benchmark and play with. We're giving you one that works best. So that's how it started. Initially, we have different components for different things you can analyze about language, from starting with what's even a word. It sounds very basic. It's obviously a lot more complex than it sounds, to what concepts are mentioned in the text, what's the text about, what's a verb, what's a noun, how's stuff connected. Yeah. And then various other things you can build on top of that.
I think one of the main features in version 2 of Spacey that is currently available is that there's a lot of pre-trained models for different languages. So people just can come and say, I want this general purpose parser that just parses my French texts and tells me what the lemmas are, what the part of speech tags are, what the entities are, like which are persons in the text and these kind of things. But I guess what we've seen over the years is that people are now wanting to more and more train their own models. So we don't want just one French model, right? I mean, there can be very different texts, like biomedical texts will need quite a different parser than just your general domain English news or French news. So I think this is also a little bit the shift to version 3 is where we're making everything much more configurable so that people can also go and train their own models. And you won't just be limited to the pre-trained models that we'll have online, even though we'll still have them for people to quickly start with. But they'll also, get much more power over training their own models, I think. So I think this also sort of reflects a shift in how people are dealing with NLP over the last years.
I feel like you've had front row seats to sort of the big shifts in language processing. And I feel like, my impression from the outside is that, some people might even, skip the parsing step for a lot of applications. Like, are you seeing that? Like, how true is that?
It's difficult to say, what all the different users are doing exactly, but this definitely has also inspired the move to version 3 of Spacey. So the transformers that are being published by Hugging Face, this huge repository of models that are extremely useful for NLP, will basically become available within Spacey 3 just through our Spacey Transformers library. So it will just be you will just be able to sort of plug and play and just put a transformer in your pipeline and use that. And if at that point you feel like you don't need a specific parser model anymore, I mean, you can definitely go and try that. So you'll be able to just, write your own model on top of a transformer output and see how well that does, basically.
Yeah, but also I think another thing, like on that topic that we've seen is, while, of course, there are a lot of interesting things, especially in research of end-to-end things you can predict that are now like, really exciting and actually work. Like, you can model like a really complex task and really predict it end-to-end. You don't need to go via all these different components and stitch it together, and that's very exciting. That's one thing people might be doing, but we've also seen that in more real-life applications, it's still often very, very useful to have different components that you put together that you can train on very specific data, and also that you can, adjust, retrain, and customize. And that's also just because a lot of the things people are actually trying to solve in industry and in real life, so to say, are things that you just can't easily predict end to end and throw like a huge language model at it and then that's it. Like that's, of course not, because otherwise those problems wouldn't be valuable and people and companies wouldn't be spending a lot of money on it. Like the most interesting and most valuable things you want to build are the things that are very specific. And so for these, you often want different building blocks you can combine and train. And that's also something we want to make easier going forward.
Could you give me some examples of things like that companies care about, but maybe, isn't as well studied in in academic circles?
I mean, I wouldn't even necessarily say that it's something that's not studied in academic circles. It's more like, okay, often one thing that people always want to do is information extraction. Companies have amassed text and text and text, and now you want to find something out about that text. And I think one example I sometimes use in my talks is, imagine you have all these financial news that you scraped, and you want to extract company sales, and you want to extract who bought which company for how much money and in which country and for what currency or something like that. That's like stuff in this sort of space is like endless, and many companies want to do that. And sure, it's something you can try to, if you have a huge language model, you can try and just throw that prompt at it and come up with some ways to prime the model. And maybe at the end of it, it will output your structured JSON representation that has all your data in it. But that's often not the most efficient way to go about this problem. Like, maybe you start off and you say, cool, I want to detect company names. Maybe for that, you could train a named entity recognizer to predict GitHub as a company, Microsoft as a company, whatever. Same works quite well for money. Actually, probably in real life, you also have tons of noise. You want to train a classifier first to filter out whether something is actually even a text you care about. Then, okay, you have these random money values. You want to normalize them. Do you need machine learning for that? Maybe not. Probably there's a quite simple algorithm that can do that for you that you want to just combine. Then you want to look up a stock ticker. That's not something you want to predict. You don't want to have like a sequence task or whatever. Like, I don't know. You don't want to have a language modeling thing. And for that, you look it up in a database or somewhere on the internet. And then you want to put that all together and put it into like a structured format that then you can feed into your database. And that, I think, is a good example of, that's super common. Predicting this end-to-end is a really interesting research topic, but not a practical approach. And it requires all these different components. And maybe some component in between is like, I hacked together a regular expression that does part of the job. Great, and works. 99% accurate. What more can you want? And so that's how we see a lot of the NLP done in practice.
Well, that's consistent with the NLP that I've seen in my life, so that makes total sense to me. I guess, what are the parts that of that kind of Spatie helps with that, or what are the decisions that Spatie's made that might be different than a more research-focused NLP library?
I think I would say the opinionated take on stuff. We're like, well, there's one, right? We're moving a bit away from that in version 3 just by giving
I was going to ask, because like with Hugging Face, there's lots of choices. So how do you handle the tension between those two goals?
Yeah, so I think, in general, we do want to give people the most reasonable default that works best, because we think that's good. And even, for example, with the transformer integrations, we've been running experiments. We've looked at what models actually work particularly well. So we can also provide like some guidance there and say, you should, if you care about efficiency and you want to use that language, probably use those pre-trained weights. But more generally, we've always started out being quite opinionated and also focused on efficiency. That's something, that's not and it's not a researcher's fault that like, your thing is slow. It's like, well, that's not its job. Like, its job is to produce these benchmarks so we can, compare algorithms. That makes sense. That's not a problem that research has. It's just that, okay, if you want to actually use a lot of these things, you need to make choices and modeling choices that actually get your job done efficiently. So that's...
I see. So even like picking models that will run efficiently.
Architectures, how we set up, the pipeline, for example, a lot of models will have embeddings for each of the tasks they're doing, and you have the embeddings copied for every component. That can work, but makes the model quite large. You're always recomputing a lot of stuff. So we're thinking about, well, how could we make it easy to share some of these things for multiple components? So you're only computing the representations once, stuff like that. Those are all decisions that we have to think about that maybe for researcher, doesn't matter so much.
I guess one thing that I've always seen in industry caring more about maybe than, I feel like academics talk about multilingual support a lot, but I feel like, in the end, many papers are written on English corpus, and, there's good reasons why, I guess, but it does seem like multilingual support is like front and center to most big companies, right? Because you have, text in multiple languages. Is that something that you've thought a lot about?
So, yeah, sorry, I thought Sophie wanted to answer for a second. Okay. No, absolutely. I mean, and also there's often more to supporting a language than just training on some random corpus that's available for the language. For example, in Spatie, our tokenization algorithm produces actual work, so it's linguistically motivated tokenization, and that also introduces a lot of considerations for like, okay, how do we deal with that language? What characters does that language have? How does that language normally work? Then to, okay, what data can we train on that actually is useful? Because that's also not necessarily the same across research and industry. But yeah, of course, there are lots of and it makes sense why everything is in English. In research, it's not you can't fault an individual researcher for evaluating and running their tasks on an English corpus, because that's just where the competition happens. But
Right.
yeah, in a more real life scenario, sure.
And I guess bioinformatics is kind of like in between, where it's maybe it's in the English, but it's just such a different domain. Like, do you suggest that people use different models if they're working in that domain? How do people think about that?
Yeah, no, you'll definitely need different models. I mean, there's just such a difference in grammar and the kind of entities and words that are being used in biomedical text. And I think there's plenty of domains like that, like finances and biomedical. These are all very different domains, and you really want to train your model on that specific domain. And so what we've seen is not just for the languages, we've seen a lot of community support. Like, for instance, if I remember correctly, Inez, the Japanese model had a lot of
and Chinese
Japanese
as
support,
well. Yeah,
and Chinese as well has a lot of support from the community, because obviously it's difficult with like not even 10 people to be able to support all of these different languages if you want them to be linguistically sound. But for the biomedical domain, actually, there's even a plugin which we have this list of plugins that we call the Spatie Universe. So people that just write different packages that plug into Spatie, and they have trained specific models for biomedical domains. So that's just perfect to then go and use that if you, or at least start from that if you're processing that kind of text. So I think Spatie is quite nice in that sense, that there's quite this big community around it. That
so that's that one that you mentioned is called SciSpatie. That was developed by Market LNAI, and there's also a project called Blackstone, which does the same for the legal domain. And I think both of these are actually, I think, great examples, because there's also, when you look at the components that are implemented, you can see a lot of thought went into what these components should do and what's appropriate for that specific domain. Like, what do we need to do differently if we want to segment sentences properly in legal text? That, if you want to do this well, you need to understand legal text and how these things are written. What are the problems? Okay, maybe we can have there's this component for resolving acronyms, I think, which is like uses a specific algorithm, and it's pretty basic, but it can be implemented with Spatie, and it just works, does the job, extends what's already there. But like, I think it's very interesting to see these projects where you can really tell a lot of knowledge and insight about the field went into developing that specific model. And yeah, I guess that's where we're back at the hammer and nail type stuff.
I want to go a little deeper, just because you were talking about this before, and we were chatting about the new Spatie library, and you're showing me all the stuff that it can do. It seems like you put a lot of thought in a lot of different components. Like, one that I just recognize as someone who's also wrestled with this problem is your configuration system. Looks super cool with the nested configs and the way that you can put in like actual logic in there. Can you talk a little bit about I feel like people might not realize how complicated setting up configurations would be if they haven't wrestled with the problem before.
Yeah, I agree with you. I mean, I think personally, this is one of the biggest strengths of the new release coming up, the version 3 of Spatie, these configuration files. Because before that, we would just have all of these defaults across the library, and then it would be difficult to really get at them and change them. And now, I mean, with the config system, we basically just define all of the different components in a NLP pipeline, so that you know exactly what is in there and what isn't. and that you can basically tune all of the different parameters of each component. And I think, Ines, I think has worked the most on actually the back end of this config system, right? And getting it to work, and all of the filling in defaults and validation stuff. And I think we battled with it for a bit, but I think right now it feels very robust. And it just, like the other day, I was just writing a config, and you make some kind of, I don't know, you write false with a capital or something such, and the system just automatically tells you, this can't be right. I mean, did you mean a string? Is this a boolean? What do you want? And so it's automatically it fails, and it's just, I actually think it's fun to work with, because you get stopped very early on in your experiment. You get this feedback from, is this a valid config or not, and can you continue with it? I mean, I'm sure.
I think just we have to accept that bugs will happen, and that things can go wrong, and especially, I mean, machine learning is just hard and it's complex. Like all these, you're basically passing these super abstract arrays and things with hundreds of dimensions from function to function, and then you're computing shit with it, and then you're passing that all the way back, and hopefully something comes out at the end. Like that is just like complex. So I feel like probably everyone who listens to this can relate to like debugging, couldn't broadcast shape blah into shape blah. I mean, that just comes up, and you're like, fuck, somewhere I have a bug. And that happened like all the time, where it's like, oh, you have the hidden width set to whatever here. And why does my thing not learn? And why does it all fall apart? It's like, because over there you need to set that same width, and you don't, because it uses the default value of that keyword argument that you've set to -1, and that's just, I don't know, that just kept coming up, and we're like, well, that sucks, and mistakes will happen, and problems will happen, and stuff's not going to get less complex. Also, you can't you're not solving a problem by just abstracting away the complexity. That's another thing. If you see these config files and it has like every parameter defined, everything in there, you might be like, oh, but that's like super complicated. How is that easy? And it's like, well, easy doesn't always mean like, no code out of the box. It's like you need to solve the problem, and that's something you can do by providing better developer experience, not just by blocking it away.
Totally.
Yeah.
And I feel like easy. Oh, go ahead.
Yeah, I just wanted to say, so I think I'm not sure when we started implementing these configs. I think around January maybe. So I think we've been working with them now for more than half a year ourselves. So I think that's also, we just saw what all the problems were, and like these hidden, like the parameter in that part of the config needs to be the same one as the nested parameter in that part. So we have all these referral mechanisms and so on. So I think we've sort of battle tested it by now, that hopefully, so these common errors don't pop up as much anymore. Yeah. But it feels kind of nice.
Yeah. No, it's always satisfying. You build something and then you actually use it and you're like, oh, that actually works. I mean, not that it wouldn't have, but it's like, and I think, when we started playing with weights and biases, that actually also came up again, because we're like, let's just log this whole config. And then we're like, oh, wow, now we can actually see how all of these values relate to each other. And it's just like works and it makes sense. And that was also very satisfying. Yeah.
It's funny what you're saying about the some of the typing and some of the stuff you said earlier about wanting things to run fast. Kind of makes me wonder what you think about Python in general, because we've actually had some very strong different opinions from different ML researchers that we've talked to. So I'm curious to get yours as an author of a Python famous Python library. What do you think about the language?
I mean, the thing is, Python is, of course, has won at machine learning, however you want to call it. But it's, and I think it's surely, of course, because Python was there at the right time in the right place. It was fast enough. It had support for C extensions, but it was also a general purpose language. Like that's something I always like to point out. The reason Python is popular and works well also for the type of stuff we're doing is that you can do all kinds of things in Python. Python was really big for web development stuff before the machine learning thing started at scale. And that also means that it's a general purpose language you can learn and get into from even something else you're doing. And that's why an AI language has also never really taken off. It doesn't work. You want a general purpose language to write in. And I think that's why Python is so popular. And that's also why I like Python. And yeah, sure, you have to put some work into it to make it fast. SpaCy is in fact, SpaCy is written in Cython, which is kind of this dialect of Python that lets you write C in Python in the Python syntax. So I feel like kind of Spacy's a bit known for like, ooh, Cython, and I feel like for some reason Matt has become like kind of known for like, ooh, writing stuff in Cython, which some people still find a bit intimidating. Or like I don't know, how did you feel about it? Because Sophie, you learned Cython.
Yeah. I think you're making it sound more scary than it is, Ines, because
really?
not the whole of Spacy
No.
is implemented in Cython. Obviously, it's just the parts that really matter efficiency wise. I think it's a very interesting question because I myself actually come from a Java background, which is obviously quite different. So I think personally, I'm really happy with the combination between Python and the typing system because you get a bit of the goods of both worlds. You have Python, which just, I mean, let's face it, just programs much more easily than Java, and there's just so much less overhead and so on. So I definitely have come to, it's definitely grown on me. And I think the typing, I do really like it because it just, especially with the whole, if you're writing your own machine learning models, and so our Think, the library our open source library for machine learning, has all of these types also integrated so that if you're trying to combine layers that just don't have the right input and output types, it will tell you again. And it won't just try to, propagate these meaningless arrays that have wrong dimension and then just crash somewhere in between. It will tell you up front. So I think that really helps, and the type system really works.
Yeah, and I think there's a lot of exciting stuff happening in the ecosystem. Like it's still quite young. It's also the static type checking, MyPy, that's all like under very active development. Just like Python itself, really. But it's very cool to see like some of the stuff actually work, and like, we're using a modern editor and like just seeing something underlined, and you look at it and you're like, oh yeah, I passed like something wrong to this function. That could have easily taken me like a long time because I passed a string and it should have been a list, and a string is also iterable. That's those sorts of bugs that like everyone can relate to, and like that's pretty cool. And also the ability to hook into that system and into the static type checking via MyPy and implement your own plugins for your own libraries and use cases. I think that's something we're going to see a lot more of in the next couple of years as the ecosystem around this matures. Yeah.
Do you see demand for other languages?
As in programming languages, or using?
Yeah, like do people ever ask you, hey, could you support Java or I don't know?
Well, I mean, it's still the Python library, but that said, there's a very popular wrapper written in R. And that's still a very popular language. If anything, I would say actually in our like space, this would be the other main language that people are working in. And sure, it might be biased because I don't know what people who are working in Java are doing because they're surely not using Python. So I mean, I don't know. It's like, oh, we never hear from people who work in Java. Yeah, because they don't use our stuff. But and that's fine. It's not fair enough. But yeah, the R, I think it's also because R and Python integrate quite well. So it's basically just this wrapper layer, and it fits in with like, a lot of people who are working, I don't know, digital humanities, social sciences. They actually, it's quite heavily R based, but they also have tons of text to analyze. So they often then use Spacy via R. Yeah.
Got it. I guess, is there other things? I mean, one thing that I kind of think of with your library and like configuration systems is a sort of like reproducibility effort, and especially I imagine like working with this range of people, especially in academia, but I think in industry too, it's so important to have things reproducible. Is there anything else you're doing to kind of move things towards like making things like clear and reproducible?
Yeah, and I think that's definitely one of the main reasons for having the config like it is, so that basically everything is defined there, and there's also, you can just set your seed of your random generator so that it should pretty much be able to reproduce exactly the same weights, even in the machine learning models and so on. So that is definitely something that we care deeply about as well.
Yeah, and of course, another part is that, it's not just the model you're training. There are always these different components. You have the data you're downloading and loading in. You have some other script that you just need to pre-process something and so on. And so another feature of Spacy 3 will be what we call Spacy projects or project templates. So it's a CLI interface that lets you work with more end-to-end workflows. So you can really define, because often, you don't just run one command, you run a pre-processing step, you download something, then you train and you want to evaluate. Sometimes you also just you only want to rerun the training if your data changed or if something else changed or if your results changed. So there are all these interdependencies, and that's something we felt like was quite difficult to do for us internally as well. So that's what motivated this idea. And so you can have it, you kind of think of it a bit like a CI config, like if you've ever configured like something like Azure Pipelines or Travis. I mean, if you haven't, well, I guess you're lucky you never had to wrangle with like CI shit. Maybe it is one of these things where I'm like, I know way too much about these things that anyway, you just basically any system that lets you define like a series of steps. You can have a file to do that. You can download data or anything else, any weights you need. And then you can upload that to a GitHub repo. We're going to provide like lots of templates you can clone. And then that also makes it very easy for people to get started. Or even something as basic as a benchmark. We're currently running benchmarks, of course, because we need to test all, the stuff we've built there. And we don't want to launch without having some numbers. But that makes it very nice because we have the steps defined. We have the data defined that's loaded. We have the processing script defined. We have everything up to the random seed set. So anyone running that should be able to reproduce that. And so if you say, hey, cool, I would love to run these benchmarks, you can do Spacey project clone, benchmark, whatever, downloads it, kind of like Git. Then, you run assets, you run a named workflow, and then it just runs it. And then you can rerun a step. It will only rerun if actually things changed. And then in that system also makes it very easy to integrate with other libraries. Like, for example, you can have a script that does something very, very specific you want to do with weights and biases that you wrote, your custom function for that integrates with a config. Or we have one project that shows how you can easily have one step that serves your model using Fast API, which is, probably one of the most popular tools. And also the developer happens to be on our team. So that's a very, people always like using Spacey and Fast API, and often people have always asked about integrations, and you're like, well, it just works. And that's actually something you'll be seeing in that integration. Like, well, is it even an integration? Because it just works. So a Streamlit visualizer, that's also pretty cool. Like, imagine you run your steps, train, you have your output, your artifact, and then you just run visualize, and then it spins you up this app. And plus tons of, I don't even know what people are going to build with it. So that's, and I'm very excited. So that's also,
That's super cool. I want to make sure I have a little bit of time to ask you questions about Prodigy and data, because that is like, my former life. I also worked in the space. So I'm also, super passionate about people getting good training data. I'm curious if you could tell me a little bit about how Prodigy works. Maybe does it integrate with Spacey in a special way, or?
We've obviously, because we developed Spacey, so for the NLP capabilities and NLP workflows, we obviously had lots of opinions and ideas. So there are lots of workflows that use Spacey. But basically, the idea started when we started working on models and things, and we wanted to create our own data. And that was also at a time when we realized, look, you don't need big data anymore. You don't need billions of labeled examples. Like, you can do that, but like often what you need is something very, very specific to what you're doing, and you want to create that, and you want to create like a lot of it, and you don't want to have a meeting and outsource it and then get it back and you're like, why is this so shit? And it's like, well, because you just asked someone to label all persons and didn't tell them what you wanted, and so they, why are you surprised? And you paid them $2 an hour, like, surprised that like the core of your application is kind of shit if that's how you treat the data collection process. So anyway, so that's something we've also seen a lot. And actually very early on when we started the company, we did a bit of consulting for about 6 months we call it, we raised the client round. So, to get some money in, and also to see what people are doing like in practice. And data collection always came up, every project. And also, it showed that like iterating on this was very difficult because people did it in a spreadsheet, and then you're like, but often we're like, maybe you should try with that type of label scheme. Maybe you want to change this around a bit. Maybe predicting something else is actually more useful. And that's that's something actually to go back to our industry versus research thing. That's another thing people often forget. If you're not in research, if you're in industry, you can choose how easy you make your your problem. Like, you can't do that if you're researching stuff. You can't be like, oh, that task kind of sucks, I'll just do a different task. But if you are solving a problem, you can choose how easy or hard you're making it. And that often needs trial and error, and you need to try things out. So that's how Prodigy was born, because we were like, we want a developer tool. Like, labeling data needs to be part of the development process, at least initially before you scale it up. You want to be building these workflows, and you want to write them in Python. You want to load a model. Maybe you have a model. You want to have the model present you with what the model thinks is like most likely correct, and then you can say yep, no, yes, no. That's very fast. Or maybe you want to correct what a model does. Maybe you want to do something from scratch. Maybe you want to label entities, text categories, lots of things. So that's what really motivated the tool. And so in practice, it looks like this. It's a Python library you install alongside your other stack. You can use it to start up the web server via the CLI, and then you have a modern web app with an interface that really focuses on one task at a time, doing it as efficiently as possible. You can move through, label some data. If you're in a good flow, you can do like, I don't know, a few seconds per example. So it's actually really viable to say, hey, you spent like an hour and created data set of a few hundred annotations. And nowadays, that gives you enough to at least validate your hypothesis. Like, you have some idea, hey, how about we predict this as a text classification task? And then you're like, is it going to work? Who knows? Like, you have to try it. I mean, that's machine learning. Like, I don't know. So
and I think the other interesting thing is also that because we're targeting developers in NLP, I've spoken to quite a few people who are using Spacey in industry, and what is interesting is when they go and just annotate a little bit of the data themselves in Prodigy, right? They can script their own recipe and they can annotate a bit of data, because that also helps you understand the domain better, and that's definitely going to help you model the challenge better. So it's really this fast iteration of how could I annotate the data, what would make sense in my machine learning problem, and basically knowing a little bit of the both worlds, rather than indeed just having thrown some data over the fence and then trying to make sense of that from a machine learning expert, which just doesn't work. So I think.
And I feel like, I mean, another difference, that you see in, I guess in real world, especially in NLP, right, is this sort of like, like loop of like, model gets trained, like a little more data gets collected in particular ways and model gets trained. I'm curious, how do your tools sort of support that kind of process? I'm sure you've thought a lot about that.
Yeah, so it's like definitely this kind of continuous, that's first just making that point to people was very important to say, your model isn't trained and done. Like, your model's never done. You need, you need to plan for like a continuous process of improving it. And ideally, you also want the model in the loop somewhere at some point, at least, because, you want to see, am I actually producing stuff that's reasonable? And, you can do that in different ways. You can actually have the model present, its suggestions, and you can, annotate them and give feedback and evaluate your model that way. You can also, one workflow we thought of is, well, what if you actually just focus on, a basic uncertainty sampling, even something very simple where you say, hey, let's just see which text categories have scores closest to 0.5, because that means that it can go either way, and no matter how you correct it, you always have a gradient to update, and you have the biggest gradient to update with in either direction, because you're in the middle, right? So there's always something to learn from, and that's another approach you can take, and also just allowing people to quickly spin up these experiments and not having every update you make to your model be a whole bureaucratic process, because that's also often what it ends up like. I mean, developers want to develop. You don't want to have 5 meetings before you can start on your model. You want to just like write code. And that's something people definitely appreciate, that like, great, I can get to work. I don't have to schedule meetings.
Makes sense.
Yeah.
So, we always end with kind of 2 open-ended questions, and I want to make sure I give you both a chance to answer these. So the first question is, when you look at kind of all of machine learning, including like, production stuff, is there like a topic that comes to mind that people should be thinking about more than they are?
I think for me personally, and I think everybody who knows me in the NLP domain knows this, is probably normalization or entity linking. And this is also one of the models that I worked that I worked on for Spacey. So basically, if you have a text and you've already been able to annotate something as being a person or a location or an organization or whatnot, that's fine and that's interesting, but you also want to know what exactly is it. So being able to give it some unique identity, preferably from a database or knowledge source somewhere. And for me, this is really a crucial step in NLP, because it kind of links your text-based analysis, because all of the other steps, or a lot of the other steps, are just based on the text itself, and it links that to the outside world and an external knowledge base that you can then use to sort of integrate your textual knowledge with other information from databases. Because, for instance, if I think back about my bio-NLP background, there's a lot of interactions, protein-protein interactions, known in databases. People record them as structured information. And then there's another set of interactions that are only written in articles. And you would be amazed at how little the overlap is between the two. So you really want to be able to integrate them and sort of combine the both sources of information. And so for me, entity linking or normalization is, it's a very difficult challenge. And we've definitely not solved it in Spacey yet, or it hasn't been solved in general yet. But I think this is an extremely interesting and crucial even step in NLP.
Yeah, no, and it's definitely also the type of tasks that we want to make easier and provide likewise for people to do. Okay, is it my turn? It might sound a bit basic, but the idea of really just sitting down and reasoning about what the fuck you're doing. Like just this, it's like, oh, reasoning. And, I'm not saying, oh, people are not thinking. It's more like often it can be quite refreshing to... often I see people overcomplicating things or feeling like very intimidated by all this machine learning stuff. And it's like, okay, so what are you trying to solve? What are you trying to do? What makes sense? What can a computer do? What can a computer not do? What's logical? And there's... What's so funny about reasoning?
I don't know. I love it.
Well, it's clearly not talked about enough, I feel.
Sitting down and fucking reasoning.
Yeah.
we all could stand to do more of that.
I should, yeah, it's a great slogan.
Not just in NLP.
Yeah, actually, just in life.
Good
just
life
think
advice,
about
yeah.
stuff. Yeah, but I do think some of that really also defines how we do things and how we think about running the company, and just like, I don't know, people spend way too much time just looking at data and trying to infer stuff that makes no sense, and that could be much better solved if you just sit down and think about it and are like, what makes sense? Should I do this? And not like, ooh, I collected some data and it says I should do this, and it's like, well, but this could mean all kinds of things. It's like, is it logical? No. Okay, then don't. So yeah. And I think then once you're there, like, it can be refreshing, as I said, because you're like, oh, suddenly things make sense. Suddenly things are doable. Suddenly your problems are solvable because you're not stuck in like some weird, technical rut, but you're actually thinking about what you should be doing.
Is there a specific story that you're thinking of? Is there been a recent like client interaction that you want to share with?
We did have people in the past who were like, well, I want my system to be 90% accurate. Mm. And then we're like, on what? And they're like, no, 90% accurate. And it's like, well, that like, what you're doing with your system will decide about how successful your system is, and that's what you want to measure, and that's what you want to focus on. And I can see how this sometimes gets lost if you not thinking about it, and if all you follow is like research, which is has kind of a slightly different objective because you're comparing algorithms.
Yeah. Well, I do think you want to kind of. I mean, I don't know. I always feel like with this stuff, when you're thinking about a big picture, it's easier to think clearly, and then you kind of push it down to like a sub problem. Like, okay, I'm trying to optimize accuracy here, and it's really easy to get lost as like an individual human, on the just trying to optimize accuracy. But then in an organization where you can't just like run thought experiments in your brain, you have to actually like talk to people. I think it's even easier for people to go down these micro optimization paths, and very hard for people to pull themselves out. So
Yeah, and it's also often, it is also the fun part. Like it's kind of this sort of this pyramid where like at the bottom is like data, and then at some point you have the code, and then you have like hyperparameters, and people are like, "Ooh, I can't wait to tune my hyperparameters."
Right. Although
when it's like,
the new Spacey library does support tuning hyperparameters very well, doesn't it?
yeah, we do expose them, but we also have to say that like we've actually, that's another thing of optimizing for more stable industry use cases, that hyperparameters have never mattered that much for the models we implemented, and still, I mean, now they do a bit more with the transformers that are just more like sensitive to that. But like we've always tried to also design things in a way that they're not like so dependent on these really brittle like random numbers you set there, where it's like, oh, 0.01, yeah, no wonder it's not working. It should have been like 0.001.
Right.
That sort of that's not productive. That's something that shouldn't have to exist. So
I mean, that is still a lot of fun, though, Ines.
yeah, but it's just like, oh,
I love playing with my 001.
Yeah, and also all this common wisdom of like, what should I use for the dropout? 0.2. Why? I don't know. Works. But it's also, I think it's good to also talk about this because from the outside, if people are looking at like the field, a lot of that is genuinely complex and abstract and difficult. But like there are also a lot of the things, that are not as deep as they might seem, and then we don't know all the answers, and sometimes we're just changing a number until like something comes out that we like.
When you look at your experience and your clients and your experience on your own of kind of taking things from sort of like, here's the thing I want, I'm starting to build a model, to like, okay, it's deployed in production and like helping someone or helping some process. I guess, where are the unexpected places that these things get hard? Like I think people sort of know maybe I need to do a little hyperparameter tuning, but you're saying, okay, maybe that's not as important, as we thought. And I think when you actually look at what ML practitioners do day to day, it's not all training models. So
cleaning data.
What else? Yeah. What else is there? Yeah, I mean, what do you all see as the issues?
I think cleaning data, OCR. It's like it's nice if you have everything in actual plain text, but often you have like a PDF that like someone scanned 10 years ago. More generally, just keeping the things together, because software is just hard. There are all these moving parts. There are all these moving parts in the ecosystem that all depend on each other. Everything, like, I mean, maybe it's because the whole like DevOps and infrastructure stuff has never been something that I was particularly into. I don't think you've ever been into that either. And like, I think it's not our team's strong like suit, but all that shit where you have to wait forever to see something fail. You like run something and then you wait, and then half an hour later you've seen it fail, and then you try something else and then it runs again, and then 2 days later you're like still debugging.
Yeah.
One of the challenges to me is what I wasn't expecting when I started, because we follow up on the issue tracker for Spacey, and then we look at the kind of problems that people run into. So what I wasn't expecting is that sometimes people just try to solve, for instance, a named entity recognition task with a text categorization pipeline. And it's often you can actually cast different NLP problems as in different ways so that you can solve them in different fashions. And I think it's sometimes difficult to communicate like what is the ideal way of going forward, or I think, trying to explain why you shouldn't use this, or maybe you want a rule-based system for some cases, and you don't need all of this ML training. And I think that's one of the challenges also a little bit for Spacey, because you have a lot of possibilities and opportunities. There's rule-based components, there's machine learning training, a lot of it in there as well. But you kind of need to know how to use the right tool for your specific challenge, and we can never know what the exact challenge is for all the users. So this is I think very difficult to guide.
Actually, that ties back in with the reasoning about stuff that like you have I don't know, you have, or like we had there's some cases where one example we sometimes show in talks is imagine you're trying to extract stuff from police reports about the victim, where the crime happened, and like, I don't know, some other details around it. There are lots of ways you can model that. And one would be, you do it end to end, you label a name as victim, and then you label something else as crime location. That's like quite the obvious way. Maybe that works. Maybe if you have a big enough language model, you can actually learn that. but often this doesn't really work necessarily. So then you have to think about, okay, how else can I decompose this problem? Maybe I should just predict whether a text is about crime. Then I can predict the locations in it. Then I can use other information I have about the text to resolve that, figure out that's a location, that's the crime location. Maybe that's where a parser could come in handy, because you can look at the syntax, especially in a language like English. There are only so many ways you can express a thing. There are only so many verbs that are used. If you cover the most common verbs, you've covered 95% of all constructions that are likely going to occur. And, maybe, it turns out it always misrecognizes some city because it, the model wasn't trained on data that had many mentions of that. Yeah, you could retrain it. Maybe you just want to put one regular expression in that makes sure that this thing is always recognized because you know the answer. So there are many ways, you can go wrong. And I guess also just people still like this idea of just downloading something off the internet and it just like magically working for whatever complex specific thing they think of. And I do, there's now, with a lot of these language models, of course, you only want to train them once, download them, and then fine tune them or reuse them. But, you should always want to train a model. Like, it's not, the question is not, do I have to train a model? It's like, you can train a model now. It's like, it's great. It works. It's, you're going to make your life so much easier. Like, you should want to train a model and not hope you don't. I mean, if there's something you want to predict, if not, you probably shouldn't. We often tell people like, look, you probably don't want to be using machine learning for this. And they're like, what? Oh, someone did ask me once, they had to implement, they wanted to implement NER for digits. And I was like, wait, like actual, just sequences of numbers and in text. And I'm like, why do you want to predict that? That's like, you can match that with a regular expression. And it's like, yeah, but my boss wants me to use machine learning. And wow. I'm like, God, dude, I'm sorry. But yeah, stuff like that definitely happens as well. Or people, trying to model things that, don't need to be modeled.
It's funny, I think 15 years ago when I was like starting, like a labeling company, I felt like people were sort of thinking of machine learning as like the scary science project that they didn't want to do. And now it's like they want to like add machine learning to like a ridiculous, like easy rule-based task. It's so funny the way things change.
Yeah, but I guess it's what people get paid for. I mean, sometimes, there's some rare cases where I'm like, God, how... some people who express like very unfriendly attitudes on the internet, who have jobs where they likely get paid a ton to do machine learning and hassling us about pretty basic stuff. I'm like, I can see how everyone wants to work in machine learning because it's probably a nice job, but like, it doesn't always mean that like what you're doing there is particularly good, but yeah.
Well, cool. I mean, thanks so much for the time, and we'll put a link to the new Spacey library in the show notes, and maybe we can have you put in some tutorials to help people get started if they want to give it a try.
Cool.
And train a digit recognizer. I bet that'll have good accuracy.
Don't forget the hyperparameter.
Don't forget to do a wide hyperparameter search.
Exactly.
No, if you're lucky, you can get to 95%. That's, I would say, pretty good on any machine learning task.
Awesome. Well, thanks so much.
Thanks for having us.
Thanks.
Yeah.
When we first started making these videos, we didn't know if anyone would be interested or want to see them, but we made them for fun. And we started off by making videos that would teach people. And now we get these great interviews with real industry practitioners. And I love making this available to the whole world so everyone can watch these things for free. The more feedback you give us, the better stuff we can produce. So please subscribe, leave a comment, engage with us. We really appreciate it.